Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are encountering. In this video, we will be looking specifically at CSEC Mathematics and the topic of parallel lines or unknown angles. We'll be looking at the past paper questions that came on this topic between the period of May 2009 until the present. Feel free to like the video and add any comments down below so we can help create more videos for you to help you in whatever areas that you are getting problems with. Don't forget to look at the description down below where we have outlined the entire math syllabus and the order we suggest you go through all the past paper solutions to cover the entire subject area. As we look at the 10 major topics in CSEC Mathematics, this video looks at topic number 8, Geometry and Trigonometry. This topic, it's a major one and it's tested for 8 questions out of the possible 60 in paper 1, the multiple choice paper, and it is worth 20 marks out of 100 in paper 2, meaning that's 2 questions. This topic can be split into 2 parts, into geometry and trigonometry, and we can subdivide geometry into parallel lines, which is what this video is about, or circle geometry, and we have videos on this topic, geometric construction and transformation. And we looked at past paper questions from 2009 until 2021, and this question was tested 3 times in the years May 2010, 2016, and 2017. Let's recap some general rules of angles. In the first one, supplementary angles, we can see that any 2 angles that add up to a straight line, in this case A plus B, will be equal to 180 degrees. So if we know one of the angles, we can find the other because there will be only one unknown. In the second case, interior angles, that considers 2 lines which are parallel being cut by another line which is called a transversal. And if you highlight in red those 2 angles there, they add up to 180 degrees, and those are our interior angles. And in the third set, complementary angles, we have a 90 degrees being cut into 2 parts, and the 2 angles will add up to 90. In this case, 40 plus 50 is equal to 90. In the fourth rule, if we have 2 lines cutting or intersecting, the angles that are vertically opposite, they are equal. And let's look at number 5, the corresponding angles. Still 2 parallel lines being cut by a transversal, and we can see that those angles highlighted in red, they are the same. It will be like one angle being translated onto the other. And the last one, alternate angles, similar situation as in number 2 and number 5. All 3 of them deal with parallel lines being cut by a transversal, and the angles highlighted in yellow are called alternate angles, and they are equal. When doing this question, we found that students find it easier if we have some steps to follow. So the first one will be to list the major rules used in angles, so that way they can easily pull out the necessary ones: supplementary, interior, complementary, vertically opposite, corresponding, and alternate. Then they identify which angle is relevant in the question, and we redraw only that angle, and then solve, applying whichever rules that are necessary. May 2010, number 6a, the diagram below, not drawn to scale, shows 2 straight lines PQ from the top right coming down to the bottom left, and RS from the top left coming down to the bottom right, they form an X, intersecting a pair of lines TU and VW, and both these lines are horizontal, and we can see they have arrows on them indicating that TU and VW are parallel. So let's bring up the rules and the 6 rules that we may be able to pull from in order to help us with this question. Let's recognize that there are 3 of them dealing with parallel lines being cut by a transversal. Those rules are interior angles, corresponding angles, and alternate angles. So part 1. Determine, giving a reason for each of your answers, the value of x degrees. So if we look at x degrees there, it is the parallel line TU being cut by the transversal PQ. So take a minute and think about it. We're given the angle 54 at the base. So if we bring up that shape looking like a Z, we have it in red, and let's extract it. Then what can we recognize? That we have 2 parallel lines with that Z shape. That will be looking like alternate angle. So, and what do we know about alternate angles? They are equal. As such, x is equal to 54 degrees. And for part 2, determine y. So look where y is. And what do we know? We know that angle up on top. So that could be looked at. Let's extract it out there. And we see that shape. It looks just like the interior angle we can apply. And what's the rule for the interior angle? That when we add up the 2 angles, they will be equal to 180 degrees. So we can say 115 plus y is equal to 180. And if we want y alone on the left-hand side, we need to remove the 115. So if we cover that off, what can we see? What's left? Y is equal to 180. And what do we do with the 115, which is on the left-hand side and is adding? When we carry it across, it will be additive inverse, or simply to say, it will be subtracting. So y is equal to 65 degrees. As such, we've solved for x and for y. May 2016, number 5A. The diagram below, not drawn to scale, shows 2 straight lines JK and JL, both starting on the left and going across to the right, intersecting a pair of parallel lines EF and GH. And the diagram indicates they're parallel because they have arrows on them. So let's bring up the 6 rules. And if you notice, we're dealing with parallel lines here. So there are 3 of the rules particularly which deal with parallel lines: interior angles, corresponding angles, or alternate angles. Determine, giving reasons for each of your answers, the value of, in part 1, x degrees. So let's take a minute and look where x is and what information is given. We know 128 degrees. Those 2 angles, x and 128, form a straight line. Let's extract it, and we can see that that will be our first rule, supplementary angles. So let's substitute x plus 128 is equal to a straight line, 180 degrees. And if we want to find for x, let's get rid of the 128. So let's rewrite it. X is equal to 180. And where do we put the 128? The 128 is adding on the left side. When we carry it across, it will be minus. And x is equal to 52 degrees. As such, we've solved for x being 52. And we can substitute in there 52 plus 128. Just double check. And it'll give us 180 degrees. So we're on the right track. And now for the second part, determine, giving reasons for each of your answers, the value of y. So look at where y is, and what do we know? Y is part of the parallel lines, and we know the 52 degrees we just worked out in part 1. If we look at our rules on the right, it looks like an interior angle. So let's highlight that. And let's pull that out so you can see it better. And remember, EF and GH are parallel. So the 2 angles there will be considered to be interior angles. And what's the ruling for interior angles? They add up to 180 degrees, just like supplementary. So we can substitute y plus 52 is equal to 180. And if you want y alone, let's remove the 52. So we'll write y is equal to 180. What do we do with 52? It's adding on the left side. When you carry it across, it will subtract. So y is equal to 180 minus 52. So y is equal to 128 degrees. So we've found x to be 52 and y to be 128. There are other ways to solve this. We could have recognized the fact that y and 128 in the diagram, those are corresponding angles. There are many different ways to solve each one of these. May 2016, number 5a, determine giving reasons for each of your answers the value of part 3, w degrees. Now, let's look at our diagram, and we have the list of rules on the right side. And why do I put this? For students who are getting problems, for them to look at it quickly and be able to extract. So if you are getting problems on this topic, then I suggest that the first thing you do when you recognize that this is the topic, or dealing with unknown angles or parallel lines, then just sketch these rules on the right side of the page. So when you're looking at the question, it's easy for you to figure out from the diagram which one it looks similar to, so you can extract that. So let's look at what we had. We found x was 52, y was 128, and we need to find w. How are we going to find w? Take a minute and think about it. W is part of a triangle, so if we can work out the other two angles, then we can solve for w. So let's see. First of all, if we extract the intersection there, and we know 128, then we can find the angle on the left. Remember that that looks like which rule? Supplementary angles, a straight line. So the angle at E plus 128 is equal to 180. And if you want the angle at E, then that's 180. And what do we do with 128 on the left-hand side? Carry it across, it will be minus 128. So the angle at E is equal to 180 minus 128, which is 52 degrees. Or we could have just said that what we got at x, 52, was a corresponding angle. What do we know with the next set? Let's pull it out. It's also a supplementary angle. So the angle at F that we want to find plus the 100 will give us 180. And similar working, the angle at F would be 180 minus 100 degrees. So the angle at F is 80. So now let's look at that triangle there. The angles are J, E, and F. The three angles add up to be a triangle, which is 180 degrees. So let's substitute. W plus 52 plus 80 is equal to 180 degrees. And why do we know we can solve this? Because in the first line we wrote, there were three unknowns, J, E, and F. And we recognize that we know two of them. So there's actually only one unknown in the question. So we should be able to solve it. So let's continue. So W is equal to 52 plus 80, 132 degrees, is equal to 180. And if we want W alone, we want to solve for that. Let's get rid of the 132. It's on the left side, it's adding. When I carry it across, it will subtract. So W is equal to 48 degrees. May 2017, number 5a, PTRS, not drawn to scale, is a quadrilateral. Q, a fifth point, is a point on the baseline PT such that QT is equal to QR in length, and we have the little symbol on the line to recognize that, and is also equal to QP. Determine, giving a reason for each step of your answer, the measure of RQT. Now look at the information we're given. We know that we have the same lengths, and we know 76 degrees, and we want to find an angle. Let's extract that triangle, and we can recognize if two sides are the same, what kind of triangle is it? It's an isosceles triangle, meaning that two angles will be the same. Which two angles? The angle QRT, the angle at R, and the angle RTQ, the angle at T. Those two angles are going to be the same. Now it's a triangle, so we know that if we add up all three angles, it's going to be equal to 180 degrees. Let's substitute, and we're going to get RQT plus 76 is equal to 180. We know that because it's an isosceles. So let's solve. RQT is equal to 76 plus 76 is 152, equal to 180 degrees. So if I want the angle RQT, that's equal to 180, and let's remove the 152 on the left side and carry it across on the right. If you notice, we're trying to write it one term under the other, one addition sign under the other, one equal sign under the other, so that it flows. And it's easy for someone who's watching this to follow the pattern. So you yourselves, when you're writing this in the exam, try and write like this. Space out your work so you have space and write one under the other. So RQT is equal to 180 minus 152. As such, angle RQT is equal to 28 degrees. May 2017, number 5A. Part 2. Determine, giving reason for your steps, angle PRT. Now, let's see if we can extract certain things to help us. PRT is that whole angle up on top. We already know one part, that's 76 degrees. We also figured out 28 degrees at the base. So if we know 28 on the right-hand side of the Q, can we find on the left-hand side? Let's extract that and see. Now that whole thing looks like which one of the angles on the right side? The supplementary angle. And what does supplementary angle tell us? That if we add up the two angles, RQT, the one on the right, and PQR, the one on the left, is going to give us 180 degrees. And we know one of those two things. As such, there's only one unknown, so we should be able to solve it. Let's substitute. So 28 degrees plus angle PQR is equal to 180. And we want to find angle PQR. So let's cover off the 28 degrees with our fingers and read back the line. Angle PQR is equal to 180 degrees. And what happened to that 28 on the left side? It was adding, and if I want to remove it from the left side, I have to place it on the right-hand side. And we'll do the opposite of adding, or the additive inverse, which is subtraction. So let's solve. 180 degrees minus 28 is equal to 152 degrees. So we've worked out that angle at the base. Now that we know that, what can we do with that triangle, that middle triangle, PQR? Let's extract it and notice that, remember, PQ and QR were the same lengths. So that means it's a what type of triangle? An isosceles triangle. And if it's an isosceles triangle, two sides are the same and two angles are the same. Which two angles? The angles that are the one on top and the one on the left. So let's write this. Since R plus P plus Q is equal to 180 degrees, remember a triangle, when you add up all three angles, it gives you 180. And we know the angle at Q, 152. So R plus 152 is equal to 180 degrees. Why can we replace P by R? Because they're both the same. So you can say R plus R is 2 times R plus 152 is equal to 180. And if we have to remove something, what do we remove? We remove the 152 degrees. So let's cover that off and let's just rewrite what we're seeing. 2R is equal to 180 degrees. The 152 was adding. We had it covered off. So if you want to remove it from that side and we carry it across, what it will do? It will subtract. So 2R is equal to 180 minus 152, which is 28 degrees. And now if you want to find R alone, we want to get, let's cover off the 2. So we get R is equal to 28 degrees and the 2, which is multiplying on the left side, when we carry it across, it will divide. And 2 into 28 is 14 degrees. As such, we found the 14 degrees on top, so we can now extract that top piece. And we know 14 on the left side and 76 on the right side. So the whole angle, angle PRT, would be 14 plus 76, which is equal to 90 degrees. And we've solved. Angle PRT is equal to a right angle. May 2017, number 5A, part 3. Determine angle SPT, showing the reasoning for your answer. So let's look at angle SPT. That's the one on the left-hand side. And they told us something else. That the angle there is 145 degrees, the angle SRT. That's a big angle up on top. So let's extract that. And remember, in part 2, we just got angle PRT to be 90 degrees, which was 14 plus 76. And if the whole thing is 145, let's write that line. SRP plus angle PRT is equal to the angle SRT, the whole angle. And as we substitute, angle SRP plus 90 is equal to 145 degrees. And we can cover off the 90 with our fingers. So let's rewrite angle SRP is equal to 145. That's what we're seeing. And what happened to the 90? It was adding on the left. When we carry it across, it will subtract. So we'll get angle SRP is 55 degrees. Then we got that 55 up on top. Let's recall that angle PSR is equal to 100 degrees. Then we have a triangle, the last triangle on the left side. So let's extract that. And what we can tell, that the angle P plus the angle at R plus the angle at S is equal to 180. The angle at P plus 55 degrees plus 100 degrees, because they gave us PSR, is equal to 180. And we can add angle P plus 155 is equal to 180. Let's cover off the 155. So angle P is equal to 180 minus 155. So the angle at P, which is properly known as the angle SPR, for 25 degrees. So let's extract that corner now, because we want to find that whole angle at P, the angle SPT. So if we extract it, we just figured out SPR is 25, and we knew 14 degrees from before in part 2. So what do? Angle SPT is equal to the angle SPR plus angle RPQ, which is 25 degrees plus 14 degrees. So the angle SPT is 39 degrees. As such, we've solved for the required angle. We've now come to the end of the past paper questions in the topic of parallel lines within the major topic of geometry and trigonometry. We've done past paper questions from 2009 until the present, all those that came in the May, June, and our next video will be on another of the topics. Don't forget to look at the topics down below to follow the order we suggest to cover the entire CSEC Maths syllabus with all the solutions from 2009 until the present.